Hello, and welcome to the Civil Engineering Tech Program's pre-recorded information sessions. This one dealing with examples and how to calculate the resultant calculations, specifically using both the graphical method and the vector analysis, or what we refer to as the table method. Let's go ahead and create a vector situation. We have a support right here, at which we're going to apply a number of different forces. Let's apply a force 1. Let's call this 100 pounds. Force 2, or we'll call this force A. Force A equals 100 pounds. Force B equals 85 pounds. Force C, we'll say this is 190 pounds. And we'll say force D, pulling back this way, is 50 pounds. So we have four forces here acting as such. But we also know that forces have both a magnitude and a direction. So if we assume that this is in 0 direction, meaning that it's at an angle of 0 degrees, and we'll say that this angle right here is 60 degrees, this angle right here is 50 degrees, and this angle right here is 100 degrees. What are the angles? Well, if this is 60, B is acting at an angle of 60 degrees. C, force C, is acting at an angle of 110 degrees. And force D is acting at an angle of 260 degrees. I got that from this right here. 360 minus 100 is 260 degrees. So we have our listing. So if we do our ID of our force table, ID, magnitude, and direction, we have force A, B, C, and D. Force A is 100 pounds, angle of 0. Force B is 85 pounds, an angle of 60 degrees, 0 degrees. Force C is 190 pounds, an angle of 110 degrees. And force D is at 50 pounds, an angle of 260 degrees. So let's go ahead and take this and we'll copy it to the next page. And so this is our locations. I'm going to write this down. So we got 100 at 0, we got 85 pounds at 60 degrees, we have 190 pounds at 110 degrees, and we have 50 pounds at 260 degrees. So let's first do it graphically. Let's solve this equation graphically. So I'm going to open up AutoCAD, and here is a center point that I can just create. I'll go up to our support. I'll create a circle arbitrarily right here at, well, we want it to be by layer. I'm going to draw a circle right here at 5 units wide. And then I'm going to draw our forces. So I'm going to draw a line from the center right here at 100 at an angle of 0. I'm going to draw a line from the center of the circle at that point 85 at an angle of 60 degrees. And then I'm going to draw a line from the center right here at an angle of 190 190 pounds at an angle of 110 degrees. And finally, from the center of the circle at 50, angle of 260. Do a zoom extents. And so there's our force vector system. That's what our vectors look like. And now what I'm going to do, I'm going to move our vectors tip to tail. Meaning I'm going to start off with a point, and then I'm going to go from that point and rotate around. So I'm going to start off with vector A, right here. So I'm going from this point to my tip. Now I'm going to move point B from the center to the end. And notice I'm using the O snaps. I'm physically snapping to these points. I'm going to move this from this end point up to here. And I'm going to move this from here up to there. Now I can, once I have all the forces rearranged, I can physically draw the resultant. So the resultant actually is going to draw from a line from right here to right there. And if I list that, now I know that my magnitude is going to be 214.3 pounds at an angle of 71.3 degrees. Now, if you're getting an angle in here of just 71, what's going on? If I have units listed and my precision is set to 0 and say OK, and I list this line out, you'll see that I just have 71 as the degree. Note that you want to change your units to at least 2 decimal places when you're doing your angles for this. So change it to 2 decimal places and say OK. And then you can go through and list out your line. And there you have it, 71.3 degrees. So let's go ahead and check this using the table method. So we know what this is supposed to be graphically. Let's check it out, see if we get that from the table method. So here's our stuff, and now we're going to do fx and fy. We know that fx equals f cosine phi. So we start off 100 times the cosine of 0 is 100. 85 times the cosine of 60 is 42.5. 190 times the cosine of 110 is negative 64.98. And 50 times the cosine of 260 is negative 8.68. And does that make sense? That force 1 would cause a positive increase in x, force 2 would cause a positive increase in x, force 3 would cause a negative in x direction, and force 4 would be a negative in the x direction. Let's go back and look at and see if that makes sense graphically. So force 1 did indeed go from here, positive in the x. Force 2 did go from here, positive in the x. Force 3 did go backwards from here to here in the x, and force 4 did indeed go from here to here in the x. So graphically that does make sense. Let's go back to our calculations, and now we'll do the y. So Fy equals F sine theta. And so we have 100 times 0 is 0. 100 times the sine of 0 is 0. A5 times the sine of 60, 73.61. 190 times the sine of 110. It's 178.54, and 50 times the sine of 260 is negative 49.24. So let's go ahead and add these up. Well, first let's check. Does this make sense? That there's zero change in the y direction with the first force. Then there's a positive, a major positive, and a negative. Let's check that. So there's zero change in the x direction with the y direction with the first force. Then we do have a change, positive in the y, positive in the y, and then we came back down. So that does graphically agree with our vector solution. And so let's go through. 100 plus 42.5 plus 64.98 negative plus 8.68 negative equals. So my fx is 68.84 pounds. My fy, 73.61 plus 178.54 plus 49.24 negative equals 202.91 pounds. And remember, we're shooting for what did we say this was if we list the resultant? We're looking at 214.3 at 71.26. And so if we take f is equal to the square root of fx squared plus fy squared. So if we have 68.84 squared plus 202.91 squared equals, and we take the second function and square root it, we get 214.27 pounds, which matches our 214.3. And our phi is going to be equal to the inverse tangent of fy over fx, both of which are positive, which puts us in the first quadrant. So the tangent of 202.91 divided by 68.84. So 202.91 divided by 68.84 equals second function inverse tangent. This equals 71.26 degrees, which rounds up into 71.3 degrees. So our resultant F, our resultant, is equal to 214.3 pounds at an angle of 71.3 degrees. And we solved that both using the graphical method and the table method, which is pretty cool. So this concludes an example of how to calculate the resultant calculations both graphically and using the table method. Thank you.